Hello students, let us discuss percentage composition. As we know that elements and compounds are represented by symbols and formulae respectively. A chemical formula gives the representation of a molecule of a substance in terms of symbols of various elements present in it. As here the formula of water is given H2O. What it shows? It represents atoms present in it are 2 hydrogen atom and 1 oxygen atom. And in formula, whenever we are making a line that represent a connection between two atoms, that is actually the bond. This is a structural representation, or we can say structure formula. So a formula gives representation of a molecule of a substance in terms of symbols of various elements present in it. As in water, 2 elements hydrogen, its symbols are given in formula, that is H. So as you have already learnt the symbols of each element and the number of atoms in a compound, it's shown by numbers 2, 1, 3 and all. Let us discuss one example. These are the 2 chemical formula which is shown here. For example, ammonia. The formula for ammonia is NH3. So the formula of ammonia is represented by NH3. What it shows that? It shows that ammonia have 1 number of nitrogen and 3 number of hydrogen. So when we count the number of nitrogen in this, there is 1 nitrogen atom, therefore we are writing N1. There are 3 hydrogen atom, so we are writing H3. So altogether it makes a formula that is NH3. So the one we are representing here, N1, that is not necessary to represent. So we are writing the formula NH3. Look at the next example, that is water. As we are familiar, water, the formula is H2O. H2O, it shows that it have 2 number of hydrogen and 1 number of oxygen. So the chemical formula is actually representing the elements present in it and also as well as the number of atoms of each element present in it. The determination of a formula of a substance involves the chemical analysis to determine. Maybe the question arises in your mind, why the water is H2O, why it is not H2O3? So that is actually the determination of a formula is due to the chemical analysis, and the chemical analysis is the analysis of the particles, the elements in it, and the second one is the relative amount of element of each type present in a given mass of a compound. Therefore, to determine the molecular mass of a compound, we begin by measuring the mass percentage of each element present in the compound. Thus, how we can define a mass percentage? The mass percentage gives the mass of each element expressed as the percentage of the total mass. How we find out the mass percentage of oxygen and hydrogen in water? As we know the formula for water, that is H2O, as shown here in the figure. So what it shows from the figure, that it have 2 hydrogen atom and 1 oxygen atom. That means there will be a particular mass percentage for O and H in the molecule. So that we need to find it out. So for that, first of all, we'll find out the molar mass. How we find out molar mass? That we have already discussed molar mass, because here there are two number of hydrogen atom into 1. Why it is 1? Because 1 is the atomic mass of hydrogen plus 1. There is 1 oxygen atom, therefore 1 into 16. 16 is the atomic mass of oxygen. So we'll be getting total 18. So the molar mass of water is 18. So like this we find out the molar mass, which we have already discussed. Mass percentage of oxygen. How we are finding out for oxygen. So mass percentage of oxygen formula is mass of oxygen into 1. Here why we have taken 1 here? Because when you compare this example, in this example only 1 oxygen atom is there. Therefore we are taking 1 here. Then divided by molar mass of water. Molar mass of water we have just now we have find it out, that is 18. Now we'll substitute the value. When we substitute the value, we'll be getting 16 into 1. 16 is the mass of oxygen into 1 divided by 18. 18 is the mass of molar mass of water into 100. Why we are multiplying with 100? Because we are finding out the mass percentage. Therefore, in order to find out in percentage, we are multiplying with 100. So when we solve this one, we will be getting 88.8%. In the same way, let us find out the mass percentage of hydrogen in water molecule. We are using the same formula, that is mass of hydrogen into 2. 2 here because there are 2 number of hydrogen atom here. So we are taking 2 and mass of hydrogen divided by molar mass of water and into 100. So when we substitute the value, mass of hydrogen is 1, 2 is the number of hydrogen atom and divided by 18 is the molar mass. When we solve this one by multiplying with 100, we got 11.11%. So as we know that the total percentage should be 100. So when we make the sum of these two, we get nearly, or we can say approximately 100%. So this is the method of finding out the mass percentage of the elements present in a molecule. Let us take one more example. Mass percentage of nitrogen and hydrogen in ammonia. We are familiar with the molecule ammonia, which have 1 nitrogen atom and 3 hydrogen atom. We'll find out the molar mass of ammonia. We get 17. Now mass percentage of nitrogen we are finding out. Mass of nitrogen into 1. 1 because here only 1 nitrogen atom is there. Therefore into 1 divided by molar mass of ammonia into 100. When we substitute the value, mass of nitrogen is, atomic mass is 14 into 1 is the number of nitrogen atom here 1 divided by 17 is the molar mass into 100, and when we solve this one we'll get 82.35%. Similarly, we'll find for mass percentage of hydrogen in ammonia. Here there are 3 hydrogen atoms in ammonia. So we have to multiply with 3 into mass of hydrogen divided by molar mass into 100. And the mass of hydrogen is 1. There are 3 number of hydrogen atom. Therefore into 3 divided by molar mass 17. When we multiply with 100, we get 17.65%. That is the mass percentage of hydrogen. And as I told you, if you want to check your answer, when you are making the sum of these two, you should get approximately 100%. So that is the mass percentage of nitrogen and hydrogen in ammonia. Here there is one problem for you. Homework. You have to find out the mass percentage of carbon, hydrogen and oxygen in glucose. The formula of glucose is C6H12O6. As we have done in the water and ammonia, there are 2 type of element are present in this three elements are there: carbon, hydrogen and oxygen. So first you need to find out the mass percentage of carbon, then mass percentage of hydrogen, and then mass percentage of oxygen. You have to find separately, and when you make the sum of the mass percentage of carbon, hydrogen and oxygen, it should get approximately 100. So all of you try this question in your notebook. So this is all we have learnt about the mass percentage. As in a chemical formula, there is a particular mass percentage of each elements are present. On the basis of this, a chemical formula is derived. So in the next video, we'll be discussing about the two type of chemical formula. Thank you everyone.